Yeah, so like I said, straightforward concept generally. It's just basically the idea, and you investigated this in the tech assignment, so you're kind of a little bit ahead of the game. Actually, a lot ahead of the game. What you're dealing with is the idea that a function can be fit to a particular set of data. All right, so a function, as in a function of x, all right, an equation that is a function-related equation. Let me just get rid of the stray mark there. So we're going to focus on lines, but in your tech assignment, you focus on other things like polynomials and exponentials, so and the sign regression. So you get a sense of the fact that it isn't just a linear function that could be fit to data. It's really any type of function. All right. So what we're going to do is figure out under what circumstances a linear model would be most appropriate for a data set, and also what we can get out of that. It's like, okay, cool, you fit a line to the data. What does that tell you? What was the point? Because as hopefully you're coming to realize in this course, the mechanics of finding a solution, like the way you would in an algebra course, really not as important as interpretation, right? Because the calculator is going to do all the work for us, so we don't really need to get bogged down with that. It's interpreting it, the information, and then making a reasonable conclusion from that. All right. So when we look at the different types of linear plots, we have the case of the perfect positive. My intent in drawing this was to get a nice line that would, well, points that could fall on a line directly, perfectly on a line, but that line would have a slope that's going in the upward direction. As opposed to the perfect negative, which is where the same stuff would be happening, but in the downward direction. Right. Now, the strong positive and strong negative, similar idea in that you want to have it going in the upward direction versus the downward direction, but there's no way you're going to fit a single line through all those points, but there's a clear and obvious trend in the upward direction. All right. This is kind of the way reality works. So reality doesn't really follow perfection. Reality's messy. And so what we're going to do is kind of take that middle ground and use that as kind of our standard operating procedure, right? So I can't fit a line that's going to go through every one of these points, but what I can do is get a line that I think would get most of them, or at least be representative of the data. There are going to be some stray points along the way, and that's okay, all right? The idea is that we can come up with a model that's generally going to represent that trend, all right? So when you talk about, like, in real life, something is showing an upward trend or a downward trend, or even a downward spiral, like these are some things that are related to mathematical models, just they're adapted to serve a purpose in everyday life, right? So this is an example of that. While I don't need to know the ideal function that would fit through every one of these points, just knowing that as x increases, y also increases, generally, that might be good enough to draw a reasonable conclusion. All right. I would even say, depending on the nature of the situation, that might be a life-changing conclusion. Like, for example, if you were looking to invest in something back in the early 90s, and you're like, well, I don't know about this Google company. Just look at some data. Oh, well, as time increases, it seems like generally speaking, their profit margin is increasing. All right, maybe I'll throw in a few bucks. That's probably all it would take, because you'd be a millionaire by now. I have an excuse. I mean, a lot of you have a better excuse. I was like in 1990. I was only 12 years old, so I didn't have any money. Some of you were like negative years old, so like you missed that train, but not through any fault of your own. All right, but what you want to do, and I keep saying this, like this is the one class that we teach here for math specifically that you could walk out and apply this in real life. Right? And so it could be a matter of just trying to find the next Google. And I mean, it's not always going to be as simple as creating a linear equation to fit some data, but just generally noticing trends. That's an important thing. All right. So same idea for the moderate, less predictable though. All right. You could fit a line to it, but this is not going to be as predictable. This is the moment of truth. I just shelled out a pretty penny for this pen. It was a good-looking 1 cent. Okay, so I'm already failing because I touched it, and so palm recognition, no, or palm rejection, I meant. Okay, here we go. I'm so nervous. I think I'm still gonna have to wear the glove, but yeah, I gotta wear the glove, but it's writing smoother, less reliable. All right, the glove's going back on as soon as I find it. But even with the other pen, it didn't even matter if I was wearing the glove because nothing good was coming of it. So yeah, I got this one for like $50 on Amazon because I went for the used option because it would have been $75, but the used option apparently is guaranteed to be brand new. So I didn't understand the whole why it would be categorized as new. There was a dent in the box that it came in, so that saved me $25. Like I'll sign up for that every day, unless it's like I don't know, something fragile like fine china or something like that. Like dent in the box could mean you got a shattered plate in there, but that's not what happened. This baby is smooth like butter. Oh yeah, look at that. So less reliable. All right. So this is more reliable. I'm just going to jot this down at pretty much everywhere. More reliable. Now, I will, from time to time, just flat out spell things wrong and have to fix it, but that's a me thing. More reliable. And this is ideal. All right. Ideal ain't happening. I mean, I would just flat out say that. How do I say this? It's one of those situations like in an algebra class, if you were presented with a nice, clean answer, you would think to yourself, okay, did it right. And you get an ugly answer, you're like, screwed something up. In a stat class, it's more like it's the reverse. If you get a nice, clean answer, you got to start thinking about where you went wrong. Right? Because real life is not clean. Right? Real life is messy. While I'm here, just figure, So the reliable cases are kind of in real life, kind of like the best we can hope for. We'll settle for the moderate cases. Anything where the data is more spread out than that is something that you're going to want to stay away from. Yeah, so in terms of graphs, scatter plots, that's what we'd be looking at. If you could find a discernible pattern in the data set, then you might be looking at something that's not a linear relationship at all, but we're only going to focus on the linear cases, at least as far as the main part of the unit. These are the other possibilities. You got your quadratic, cubic, quartic, exponential, natural log, and the none situation. None is the easiest one to identify. I hit the wrong button. It's the easiest one to identify because you look at it and you don't see a pattern. That's simple. Typo for somebody. I actually fixed it in my notes, but it's still there. This natural log and the none, they're just floating out there in no man's land. Look at those. They shouldn't be there. All right, the ride may be over. No. Just gonna say, because I thought the pen stopped working, but I think it's still alive. All right. Oh, I do have a stray mark though. Let's get out of here. You kidding me? All right. So 2 ways to determine whether 2 variables are related. You can look at the scatter plot, just kind of eyeball it, and the other is to determine the correlation coefficient. And we'll get to that, but it's a more mathematical approach. And I promise you that if you had to do it by hand, it would be one that you would not be overly enthusiastic about. But calculator's going to handle it for us with great ease, so we're in good shape. When you're interpreting a scatter plot, you're just looking at the overall pattern. If it has a significant upward trend versus a downward trend, and if you notice anything that deviates from that overall pattern, that value may be what's called an outlier. All right. It could also be an influential point. So I define those later on, but basically, if you have a point that's an outlier, it lies off the general trend of whatever the line is that you're using to model your data. So just 1 or 2 points that are kind of out of whack. You know, you have all the points that are organized. Most of them fall on the line, and then you got like one, just off in Toledo and the other in like Albuquerque. You know, they're nowhere that actually makes sense based off of the general trend of the data. So it could be influential, or it could just simply be an outlier. A data point would be influential, and this is all in your notes, if it's an outlier in the horizontal direction, right? So, because you could have a point that's off the beaten path on the high or low side. You know, here's your line. You could have it on the high or low side, or maybe it could be on the east or west side. You know, so if that's the case, you would define them in different ways. The reason we call it influential is because it has a significant impact on the slope of the line. One of the things that really defines the nature of a line, or probably the most important thing that defines the nature of a line, is that line's slope. All right, because a line has a slope and a y-intercept. Slight changes in the y-intercept, not much of a change in the overall trend of the line, but a change in the slope could have a massive change in the overall trend. Right? In fact, it can go from being a positive trend to a negative trend. Right? Whereas if you change the y-intercept, maybe it just shifts it up or down a little bit. Right? But it still has an upward trend. It's just your starting point would be a little bit different. Right? So one of them could be actually catastrophic. The other, it could be okay. All right? But we'll get into that in a little bit. But really, this is just emphasizing the idea that you want to be on the lookout for points that are, well, we can call them striking deviations from the pattern. Those points would be known as outliers at a minimum. Those outliers could also be influential points. All right? So we look at this data set. We're not even getting into the numbers yet. I just pop a line that I think is the best fit model. You know, I'm looking at the bulk of the data, and I see that one stray point off on the side there. If that one point wasn't there, I would say that would be a reasonable fit for the line. With this point, the one that's all the way past that, honestly, the numbers don't even matter, so I can't tell. That might be a 14.0, but it could also be like 140. I have no idea. All right, so this is an outlier in the horizontal direction. Hmm.
You could just look at it and know that it's an outlier without doing the formula and figuring out how to split it.
Yeah. So we call this an influential point. I gotta imagine that a really good skill, if one were to consider going into the teaching profession, would be to learn how to write without placing one's hand on the surface of the thing that one is writing upon. Because that appears to be my big issue. If I could just write like this, I'd be fine. However, that would be a problem. It would be quite painful. So, here we are. But, you know, for things like drawing lines and stuff, I'm alright. Alright, so we can get a sense of the direction. We can identify an outlier visually just by looking at it. If it's an outlier in the horizontal direction, we call it an influential point. Just by looking at the general trend of the data, we can decide whether or not the trend is a positive or negative trend, so a measure of slope. So this one would be a negative slope. And this one would be a positive slope. All right, and then we also want to look at the strength of the relationship. So the three ingredients that we're looking at when we're evaluating a graph would be, like I said, whether or not there are any outliers, the direction of the trend, and the strength of the trend. Like in the case of the first one, I did not use the line draw tool. That actually did not come out too terrible for not using the line draw tool. However, that's what I wanted. That's we call that, and I'm going to be very specific here, very strong. And this one would be very weak. That's one thing we sort of have to get used to with statistics. You know, we talked about this before, but when we're describing graphs, sometimes it's just a matter of throwing a couple of extra varies in there. If it were a little tighter, I might say very, very strong. All right. But we kind of quantify that by saying virtually perfect. You know, you could say that, but just throw a bunch of varies in there and you're good. You know, like it's really not more complicated than that. You'll find that some aspects of statistics can be incredibly wishy-washy. And in fact, later on in the course, I'll show you how you could have a set of data and some summary statistics related to that data, and you can draw two exact opposite conclusions depending on what your personal goals are. All right. So that if that doesn't give you a sense of the wishy-washiness of the subject area, I don't know what will. All right. So just throw some varies in there. The case of no correlation, no, like in the case of this, how close to the do the points lie to a simple form such as a line? The strength, you could say it's like has no strength whatsoever. Well, that I don't know that you can make that claim. You know, so it don't ever speak in absolutes. As long as you don't do that, you'll be fine. Because you know only Sith deals in absolutes. So you wanted formulas? I got formulas for you. Look at those babies. Yeah, you didn't want formulas. But for the wow factor, I made sure to throw them in here. They really pop off the page at you. I'm just letting the page breathe for a second here, and it's like, whoa, it's crazy. So this is automatically built into your calculator among many other statistical functions. The calculator will tell us two very important things related to linear regression. It'll tell us the correlation coefficient, known as R, and it'll also tell us the coefficient of determination, which I believe is the better measure. Oh, my pen timed out. I see what. Oh, I just got to push the button every once and again. That's the ticket. All right, the coefficient of determination is this R squared thing. All right. That's funny. I don't think I ever wrote coefficient of determination, so that's, I guess, where you come in. I just can't do it this way. All right, so it's officially not the pen. Because like I said, this pen is smooth as silk. It's the hand recognition and rejection part of it. So coefficient, those typos are pouring in. I think the Surface Pro here, I think it senses confidence from me, and when it thinks my confidence level has gotten too high, it strikes back. Yeah. Smooth like vanilla ice cream. Smooth like Billy D. Williams' voice 30 years ago. All right, so these are our measures here. R squared, I mean, honestly, I gotta tell you, these tables, I made them all up. Yeah, that, like, it's all a lie. So this is how it works. The closer your R value is to 1 or -1, the closer your scatter plot is to falling on a line perfectly in the positive or negative direction. The closer your R squared value is to 1, the closer the relationship is to a perfect relationship. All right. So about 15 years ago, I gave that same spiel to my students. And they were like, okay, so how do we know if it's, well, if we know when it's perfect, but how do we know when it's like really like close to being perfect versus like very strong versus moderate versus like whatever. Like we need a sense of scale. We need a chart. So I was like, all right, I didn't want to have to give you the chart, so but I'll write down the chart for you. This comes straight from the Statistical Association of America. And then I drew the chart. There is no Statistical Association of America. So I drew the chart up on the board because I used the blackboard back then. And this was the chart. Or the one on the left anyway. Just made it all up. Because they needed little cutoffs. Just for the concrete mind, they needed definitely a visual, but they needed benchmarks. They needed to say, okay, if I'm above a 75, I'm in the strong range. If I'm above a 50, I'm in the moderate. Because they want it to be like grades. Not really realizing that these R and R squared values are comparative values. So 1 is the ultimate objective, 0 is the ultimate thing to be avoided, and then everything else is relative. All right, so if I get an R squared value of 0.75, that may be great, or it may be terrible. It all depends on what you're comparing it to. All right, so if I have a distribution of test scores from, let's say, 10 years ago, and I've been kind of working on my craft, trying to become a better teacher. 10 years ago, I might have an R squared value of, let's say, I'll say 0.5. All right, is that good or bad? I don't know. I have nothing to compare it to. What it means is that the data are loosely organized. I could find a line that'll fit it, but the line is not going to be a precise fit because there's so much variation. But then 5 years ago, so 5 years after the 10-year in the past moment, it got to a 0.75. All right, so what that would mean is that the data are more tightly organized at that moment in time than they used to be. All right, now maybe these days it's like 0.8, so it's even more tightly organized. All right, so what's happening is now that I have data collected over 3 separate instances in my own history, I can now compare one set to another. All right, it's standing alone. It doesn't really mean that much. It's just, is it close to 1? Yeah. Okay, so I guess it's pretty good. We can use the line. All right. If it's compared to something else, now you have the means to make a decision of like which is better. All right, which would be a better data set in order to draw a meaningful conclusion. All right, the one that obviously has less variation. All right, that's all this means. So you can look at the chart if you want. I just put it there because there's always a handful of folks, I mean different learning styles, that are like, I just need you to tell me when I get this number, what do I write down? That table will tell you what to write down and you won't be wrong. But if you got a 0.92 and you wrote down pretty freaking strong relationship, you're not wrong either. You know, so it is all relative. All right. Now this is just look at all that. These are screenshots from a graphing calculator that are designed to walk you through this process. Ideally, it would be a one-stop shopping for anybody looking to navigate through this idea of correlation and regression. But as we all know, there are multiple calculators living in this environment. Some 83s, some have 84s with the older software. Some have 84s with newer software, and some have 84s with the newest software. Because remember last class, there was a feature on some of your calculators that I didn't even know about. Honestly, I think my calculator may need an operating system upgrade. So these instructions will give you a general gist, but you want to just have an idea of what you're looking for in the calculator. The title of this part of the lesson is called Linear Regression. So you could probably guess that you're looking for the function in your calculator that says something to the effect of linear regression. I'll show you how to get there. But before you do that, all of our calculators need to have the diagnostics on.
Yeah, we get to that. I think you said that you will have a confused with yourself because there were 3 ways of evaluating graphs: straight trend, positive or negative, and then just the
Outliers. Outliers deal.
So not type.
No, because we're just gonna. Well, the type of line would be the orientation of it. Yeah, we're just gonna focus on linear.
And then regression, so we use just how it's just putting the line to a set.
Yeah, exactly.
And we're not going to do variables. Left hand.
We're not gonna do.
I don't know. You put variables as notes.
Oh yeah, we're gonna talk about that, but in the context of an example. It does not. All right. But what you want to have, and I'm going to show a couple of ways to do this because some calculators don't have this. You want to go into mode, and then scroll down till you see the one that says Stat Diagnostics. Scroll to on and hit enter. Make sure that that one is on. It will not. To the point where I don't, maybe I'm just not knowledgeable enough. I don't know why that's even an option. Like, it should just be stat diagnostics are on and that's the end of it. Like, they shouldn't even give the user an option to turn it off. Like, it does not interfere with anything else, to the best of my knowledge. Right? While you're here, you see, if you see stat wizards, yours should be on. So if yours is on, if yours is set to off, then you probably haven't been getting displays that are similar to mine when I do something on the calculator. So that would be the explanation for that. So the two items that reference statistics, stat diagnostics and stat wizards, both should be set to on. So you just hover right over or scroll right to it and hit enter on the word on. All right, then quit out of here. Now, if you don't have that display, like you go into mode and it doesn't show up, go into catalog, second 0, and you just have to scroll down to the one that says diagnostics on. All right. A shortcut, because the alpha lock is on, would be to hit that X to the negative first key, which is right next to sign. Right above it, it says D. It'll at least jump you to the D section. So you'll see that there are two options for diagnostics. One is off and the other is on. We want on, hit enter. It brings the command into the home screen. Hit enter again to actually activate the command. Right? So if you didn't have the mode in that mode menu, you didn't have the option to turn diagnostics on, this is how you do it. This is a one-time deal. All right? You don't have it won't turn itself off unless you either reset your calculator or turn it off yourself. But for some of us who have the rechargeable calculators, we know that if we let our calculators die completely, that's just like resetting it. All right, so never let that thing die, and you won't have a problem. If you do, then you're right back to square one. All right, so you don't want that. All right, so the minute that battery starts turning red, plug it in, 5-10 minutes, then you can remove it from the charger, and then you're good to go for a little while. All right. So these are the steps to create a statistical graph related to a linear regression model and scatter plot, but also it'll help. It's just a good resource when you want to actually find out the results of a linear regression. All right. But we'll come back to that because it's just notes for now. Making predictions to determine y given an x. You can either do it algebraically, which you don't want to do ever. I'm going to actively discourage you from doing that. Or you could use these functions on your calculator, which are not going to be meaningful until we actually get into the mechanics of it. Right? So the second bullet point all the way. I don't want to speak for everyone, but in most cases, that's not fair. I want to be reasonable about this. And by now you know that I generally have the majority of the conversation in my mind, and only certain words of the conversation spill out, and so I don't always make sense. But I do eventually settle on to what I want to say. In my experience, more than 50% of the students who take this course are doing so because they need math credits and they heard that this was the easier of the options. Plus, it's generally a requirement for some kind of field that involves statistics in some way. All right? Those are the two big reasons why lots of people take this course. Again, it's not a catch-all because there's plenty of people that just want to learn more math, right? And so for you, I'm not talking to you. For the folks who despise math, You might despise math because of algebra, right? Because of actually solving equations and all that stuff. So if you're resistant to using a calculator approach and you want to do something by hand, I would encourage you to think about why you're taking this class to begin with. Like, well, I wanted an easier math. I didn't want to have to do algebra anymore. Or maybe I want to focus on analysis rather than the mechanics of just solving for x all the time. Right? These two things that I just highlighted are going to get you the answer using the technology. You're going to be able to avoid the thing that you don't like, solving an equation using algebra. And this is the best part, it's flexible. It allows you to use you could use this approach for any type of function, not just a linear function. All right? So if you find yourself using an exponential function or a logarithmic function or a trigonometric function or other fancy name function, these two techniques will work. You could end up getting to a stopping point with the algebra. All right? So that's the best I got for motivation. All right? So most people are going to do what I say in terms of the process anyway, but there's always in the back of the mind, like, why can't we just do it the old-fashioned way? Trust me, this is better in the long run. All right? Now, if you love doing algebra, do it this way and then solve it with algebra just for fun. All right? That is my spiel on using the calculator. And it's also a, I guess harbinger is the right word, because there's a fair few steps involved, and I usually get a lot of eye rolls and heavy breathing. Not the weird kind, that kind, where it's like, why do we have to do this? And it's worth it. So we'll get into the example. Ornithologists, who are of course scientists who study birds, tag sparrowhawks in 13 different colonies to study their population. A very relatable example where we've all been there. They gather data for the percent of new sparrowhawks in each colony and the percent of those that have returned from migration. All right. So we have some data, we have some context, we have some data, and then we have instructions. Use your calculator's regression function to find the equation of the least squares regression line. Bless you. So one thing I should mention, least squares regression line, linear regression equation, best fit line, they all mean the same thing. All right? So linear regression equation, that's supposed to be an of, best fit. Best fit model. I mean, really anything that involves the word line in some capacity in this unit is going to be referring to the same process. I'll take it as a typo, a little spacing issue right here. Shouldn't be so close to the colon. Very easy to lose a data point that way. All right, so we're gonna put the data in our calculators the same way we put every other data set in our calculators. We have the percent return that's going to go in L1, and the percent new is going to go in L2. These are this is two variable data, also known as bivariate data. I think that sounds overly fancy. Bivariate, multivariable, even scarier. You got two variables instead of one variable. And we want to see if there's a relationship between those two variables. Now, honestly, all kidding aside, I did choose this example to be the first one because I wanted something that would be completely unrelatable. so that you don't go into the problem with any preconceived notions. Because I've done the classic age versus height and stuff like that, and you're like, well, if you're 6 months old, you're going to be shorter than when you're 6 years old. Why do we need data analysis for that? You know, just wanted something in a vacuum. 18, couple of 18s. All right, double check this about 5 or 10 times before you get to work. I'll make sure the data lines up on a test. You know, I'll even take that as a typo. Why can't I make it line up here? I'll make it line up here. Should have done that like 6 years ago, but I didn't. So here we are. Now I'm going cross-eyed and paying the price for it. All right, I think it's good. All right, so my data's in. So this is what we're going to do. Quit out of here. Second mode. And this process is detailed on the previous page, so I'm not going to write anything down. Stat, calc. Now there's actually two options. So when you look at this process, you see that we have stat calc 4 as the option. But as you go down the list, you'll see that there's also a stat calc 8. Oh, I didn't even have to scroll for that. Let me just do this. Stat calc. You'll see option 4 and option 8 both have lin reg. And they'll both give you an equation that best fits the data. It's just in one case, the A value represents the slope of the line, whereas in the other case, the B value represents the slope of the line. Why would you have two different things? Well, it's because different fields use linear regression for different things. So in a purely mathematical sense, they would use option 4, but statisticians use A plus BX. So every textbook that you see actually uses that option, the option 8 version of it, for statistics specifically. Because, and honestly, it actually makes more sense, because if you're talking about variation from a particular starting point, wouldn't you want to start with the starting point? That's what the B value is. And then the slope, or the A value in that case, the slope talks about the movement from that starting point. So the A value should pin you to the y-axis, and then the B value should take you on a journey from there. Right? That makes sense to have the y-intercept first. It's just in every algebra class that ever existed, they always teach y equals mx plus b, or y equals ax plus b. And then that screws everything up. All right, so long story short, too late. Option 4 or option 8 doesn't matter. Pick one. They both have lin reg in it. Just don't hit option 9. It has ln reg. There's no I in there. That's natural log regression. That's not linear regression. All right, so option 4, it brings you to this display. My X list is in, my X values are in L1. My Y values are in L2. Those should be the default settings. For some reason, this has a frequency list at L2. I don't want that, so I clear it out. Now, I also wanted to store my regression equation. This is a big deal. All right, so we want to store it as a graph, because this is going to be a line equation. All right, and we can graph lines with these calculators. So in order to store that, we're going to hit alpha, trace, and then y1. All right, now for the 83, that y1, you have to hit a different series of keys. So if you have the 83, then you would need to hit, in order to get this, the vars key, and you have to go to y vars. And this works on all the calculators. It's just the shortcut keys are on the newer calculators. And function. And then finally you'd select y1. So, but for the 84s, it's just alpha trace. And then select y1. And turned off again. And everything that's in this calculator is in the catalog, so if you ever get jammed up and you're looking for a function, second 0, and just start scrolling. All right. Go to calculate, and you get all this stuff. It's a wonderful display. It gives us everything we need. Now, if you don't have the R squared and the R values, then you didn't turn your diagnostics on. Which means that either you screwed it up when we were doing it, that's the better one, the better reason, or you just weren't paying attention when we were doing it. That's the bad one. So if your R squared value and R values do not appear, I can walk through the process again, but you have to admit that you screwed it up, because if the alternative is that you weren't paying attention, you don't want to admit that. So it's the lesser of the two evils. All right. So does anybody need me to go over the process again for that? Yeah, nobody's going to admit it now. So in case you missed it, if you need to turn your diagnostics on, you hit mode, and then you go down to the one that says stat diagnostics, and you make sure that it's on. A common error, so this goes in the realm of I screwed it up. What a lot of people have done in the past is they'll put their blinking cursor right on, and then just quit out of here, and just assume that the magic happened. You got to hit enter on the word on. And if it sounds like I'm insulting your intelligence, it's not intended. It's just that's something that has been a problem for people in the past. All right, they think just by putting their cursor right on the word on that they've accomplished the objective. That is not accomplishing it. All right, so hit enter on the word on, and then we go to stat, calc, 4, L1, L2, should be your default settings. There's no reason that should ever change, unless you decide for some reason to go rogue and put your information in L3 and L5 or something like that. But no, just put your data in L1 and L2. Alpha trace y1 and calculate. Right? Enter on the word calculate. So it asks us for the least squares regression line. That's the A and B values. They give us what the model should look like on top. All right. So that's nice. A little reminder, this is what your equation should look like. And then it tells us what the A and B values are. We just round to 3 significant. All right. So y. Now we put a little hat over the y. That's a poor quality hat. Let me do that again. I'm going to do it out here actually, just so I have room for the hat. It should be a triangular hat, and for some reason this is not cooperating the way I want. Like a little carrot symbol. Better. So the calculator doesn't put the hat on the y, even though it should. It just doesn't. The A value, we'll go 3 significant, is negative 0.304. X. And then your B value is about 31.934, so plus 31.934. All right, handwriting aside, it's basically what you see on your calculator screen. So the only thing you'd have to remember is that the y gets a little hat, and the reason why is that actually refers to a predicted y value. All right, so this is predicted y. All right, it's a predicted y value. So if I were to take any of these x values from the percent return category and put it in for x, it would give me a y value, but it wouldn't necessarily correspond with the y value that actually happened. All right, these x values, the predicted percent return and the percent new, these are what happened. All right, so the idea is that the new should be a predictor of return, and so like these arrows are terrible because it's not lined up. But if I plug in a 74 into this function, then I should get something near 5 if my function is accurate. All right? If I don't, then my function isn't that accurate. All right? But we can test it out now because the next question is asking us to determine the percent return if the percent new is 25. And the other way around. All right, so what this is telling us to do is find the x value if y hat is equal to 25. All right, and then part C is asking us to determine the y hat value, so find y hat if x is equal to 90. All right, both of which could be done strictly on the calculator. All right, you would not even have to write this statement on the test. You would just tell me what the answer is. All right, so that's beautiful and dangerous at the same time. All right, so the beauty part is easy enough to visualize because it's like, oh, I could just write the answer down. The danger part is, if it's wrong, I have no way to give you partial credit. So you got to be careful. All right, so we'll go through the process and take it from there. So first I want to create a stat plot. All right, and it's going to be specifically a scatter plot. So second y equals. We have a fair amount of experience with these stat plots now, to the point where we know where to find them. We hit second y equals, and that if we hit enter on the first plot, we could change it from one type of graph to a variety of other possibilities. All right, so what I'm going to do is select the very first option, which is the scatter plot. All right, that one is, I think, kind of on the same level as a histogram, where just by looking at it, you know what it is. It's got points scattered all over the place. Therefore, it is a scatter plot. All right, I don't know where to put it. I'll just tuck it down here. All right, so that's the kind of graph that you want. L1 and L2 are your defaults, so that's beautiful. It's ideal. Mark is just how you want each of the points to be displayed on your graph. I always select the box one because my vision is terrible. It's bigger. That's all the explanation I have for that one. So once you have that information set up properly, zoom 9. We always live out of zoom 9. Zoom stat. So now you have a scatter plot, and also it plots the line of best fit. And you might say, how did it know the line of best fit? Well, don't do this, but I'm just going to hit the y equals key. By doing this step where it says store regression equation, when we put in y1, it stored it in as the equation y1. And in doing so, it allows us to plot, or allowed us to plot that equation concurrently with the scatter plot. All right, so that's nice. It's one extra step that we don't have to worry about. But we do have to get the answer to these questions. One part is going to be easier to get than the other. All right, finding a y given an x, very easy. You do it in the table of values, but you could also use a function that I'm about to show you. But finding an x value given a y value that's what I was talking about before when I would say people are kind of resistant to this approach because it's like, oh my God, it's like 3 steps. I don't want to do that. And to be fair, some of us in this class, like day 1 of the class is the first time you ever touched one of these calculators. So these 3 steps may be like, I forget that. But I promise you, it gets better with time. So, So you went in here and you accidentally hit clear like I just did? Oh, yeah. You're like, this garbage is just going to get in the way. Yeah, I'm in the same boat. I don't know what I'm going to do either. Right, so what you can do, because we just did this calculation, if you're in your home screen, hit second enter, and it should bring up your linreg stuff. Hit enter again, and then when you hit y equals, it should all be back. Okay, so then what you're going to do is hit stat, calc, option 4. Make sure L1 and L2 are there. Install a regression equation, alpha trace y1. And then calculate. And then when you hit y equals, it's going to be there. No problem. And then the zoom 9 to make sure that you have that nice looking graph. Now, nice looking graph as in it produced a graph that is nice to look at. Not nice in terms of the strength of the relationship. I mean, these data points are all over the place. It does seem to have, I would call this a reasonable downward trend. And basically, if you can observe a downward trend, you can call it reasonable. Okay? If you're looking at it and saying, I can't tell if it's going up or down, then you would say that there is no discernible trend. All right? That's a fancy way of saying that I don't see anything. Like there's nothing going on with this data, right? So no discernible trend. I can't say that. It does look like it's going downhill, but it's not a tightly grouped data set, right? So we've got to be mindful of that. So to find an x given a y, to find a y given an x. That's the first process up here. Yeah, like if you're doing it by hand, it's just a matter of subbing the y value into the model, and so that ugly equation that you cleared out with the 0.3, the negative 0.3, that nastiness, you could plug the y value into that equation, so 25 in here, and solve for x, or you can do what I'm about to show you. All right, you go into y equals. In y2, whatever the y value is, just type that in this case 25. Hit graph. I mean, you could do your zoom 9 again, but we already have the parameters of the window set up, so we're in good shape. Hit graph, and a horizontal line should appear. If it does not appear, it means that we need a better window in order to make it appear. All right? So that's the part that people start with the eye rolling and the big deep exhale. Forget it, I'll just do the algebra. No, we need a better window. All right, so how do we get a better window? We hit the window key and we give it a better window. All right, so the y max is the largest y value on that graph. Well, I needed to show the 25, all right? So, this is not that pen. I need to do it this way. So, that 25 needs to appear on that graph. But this one's only going up as high as 22 and roughly a half. So, make your y max something bigger than 25. No, don't go crazy. Don't make it 1,000. But like 26, 30, I'll go 30. And then hit graph. Anytime you manually manipulate your window, don't do the zoom 9 again, because all it's going to do is bring you right back where you started. Just hit graph, and now you have a line appearing. Okay? We need to show an intersection between these two lines. All right? It looks like that intersection is somewhere to the left off screen. All right, so that means that my x values, my lowest x value is still too high. Question. Graph. So I need to show more to the left. So whatever that low x value is, I need to go below that. So I'm going to hit window. See, this one is starting off my x min because remember the calculator is making decisions in terms of the window based off the data set. It's not thinking about it critically. It's thinking about it strictly by the numbers. It's saying this is the window you want because that's what the data shows. But you're saying, well, I want to see a little bit more, all right? So I'm going to make that x min value something smaller. How small? Like negative 1300? No, like something reasonably smaller. Like you can go down to 30. I don't know if that's going to get the job done. Maybe go down to 20. And as long as you show, you could have gone down to 0. That would have been fine. If you go down far enough, it'll show an intersection on your screen. As long as it shows an intersection, you have an appropriate window. All right. And so that's what we have here. We just need to actually get a solution from that window. All right. So this is where that next step in the process comes in. All right. So the eye rolls and the exhaling and all that stuff. All right. So again, process. Enter the best fit equation into your calculator. Done. Enter the given y as an equation. Done. Then find the intersection. We're going to hit second trace. Option 5 is intersect. So you can scroll down and hit enter on 5 or just the number 5. I put in here follow the instructions on the screen. They're kind of vague, but it's basically identifying the two graphs that you want to find the intersection of. So my cursor, my blinking cursor, is on the first graph. You can see the equation at the top of the screen. It's the regression model, the negative 0.304, etc. So hit enter to lock that in. Then it moves to the second equation. If there's only two graphs on the screen, it's only going to select the two that you want. The issue is if you have like 3 different functions on the same screen, the calculator won't know which ones to find the intersection between. But for this, you shouldn't have a problem. So hit enter again, and then it asks you for a very mathematical process. It asks you to make a guess. Bless you. Honestly, they just wrote guess because there wasn't enough room to say, make sure that your blinking cursor is closer to the point of intersection that you want than it is to the one that you don't want. All right, there wasn't enough room for that, so they just said guess. So basically, it's just telling you to scroll to the left. I think I can hold it down actually on this one. And then hit enter a third time. Okay. And at the bottom of the screen, it should say what the intersection is.
Wouldn't it give you the intersection if you just scroll down to the blue line?
If you scroll down to the blue line. Scroll down to
Well,
the blue line?
just arrow down to the blue line.
If you did, I'm not sure.
I thought it was just comparing the slopes.
Because I know that it's going to drag you to the only intersection on the screen if there's only one, so, but I don't know if it's necessarily related to the blue line. I'd have to look at that. I'm not really sure. I got to give that a look. So anyway, we get 22.808 as the x value. That was the one we were looking for, so that's it, 22.808. All right, I'll take that from the top. Just walk through it again, just another look. So we just hit zoom 9. We got this graph. we typed in the 25. Now you got to know certain things, like there should be a horizontal line appearing on the screen. I don't see one, so now I'm on the lookout. So I go into window and I say, okay, look, my Y max, that's why that horizontal line isn't showing up. I need it to show a 25. It's only going as high as 22 and change. So I change that number to something bigger than 25. Doesn't matter. You can make it 30, you can make it 50. I made it 30 before, so I'll make it 30 again. Hit graph. Then you see that if you only could go a little bit further to the left, you'd have an intersection, right? Because they are closing in on one another. So go back into the window and make your X-min smaller. I made it 20. You can make it even smaller. I think I made it 20. You can make it smaller. You can make it 0 if you want. But I made it 20 before, so I'll make it 20 again. All right. Now we have an intersection. To get the solution, we hit second, trace 5, enter, enter. Now again, if there's only one intersection on your screen, it really doesn't matter where your guess is, it's going to drag you to the solution. But, for peace of mind, scroll right to that, as close as you can to that intersection point and hit enter. But you can see, I'll just hit enter here and it drags me there anyway. All right. And you could also, if you wanted to, second trace 5, you could type in the number of your guess. You don't, because scrolling is kind of a pain. Like, let's say you thought it was 24. You just type in the 24. It accepts a typed in guess also. All right. Now, going the other way, finding a Y hat when you know an X value, that's much easier. What's that? Once you have an intersection between the two lines. Oh, then you got to hit enter again. Yeah, so if you see guess at the bottom of the screen, you just got to hit enter a third time, and you'll get it. All right, so for this one, you could just do this right in your home screen. So to find a Y value given an X value, you just hit second. Well, you can do it a couple ways actually. I'll show you. I'll show you a different way that's on here, because this way relies on you having a window, an appropriate window, and it's not always going to play out. So in your home screen, so I'm just going to go. Meh. Oh, actually, part of that is okay. Hit alpha trace Y1. Yeah. Oh, yeah.
Thank you.
No problem. Alpha trace Y1. Open parentheses. Type in the given X, and then you close parentheses and hit enter, but you actually don't even have to close parentheses. So I would type in the 90, close them up, and hit enter. And we'd be looking at about 4.572. All right. So one way you could definitely see the benefit of the calculator. The other way you're kind of questioning it. It's more trouble than it's worth. I understand that. But there is an element of muscle memory involved in this, that you start to get a little bit more experience with the concept. It does get a lot easier. All right. I guess that's true for a lot of things, but especially so with the calculator, because most of this is just getting to know the functions. Question? Oh, based on the context. So the first value, the first set of data that they give you is the X data. The second set of data is your Y data. And then when they say determine the percent return if the percent new is 25, then they're telling us that the Y has to be relative to the new, and therefore the X You know, so it's strictly based off context. All right. So then, the outlier and influential point, and this is the last thing that we're going to do. It's very, very straightforward. It really just involves kind of investigation. Because this one's not asking us to solve for anything in terms of x's and y's. It's just asking us to determine if there's any outliers or influential points. All right. Also, the linear correlation coefficient. And I'm about to make a typo suggestion. So I'm going to clear out all this data. It's bittersweet. Put all the work into typing it in to begin with. You don't want to say goodbye. But it also means that you're done with that problem. So there's something to that. I will tell you that on the test, which we'll talk a lot about next class, I will send out tomorrow. I'll send out a breakdown of the different topics that'll be on it. I'm sorry, the different questions, because topics are obvious. It's like everything that we covered, right? But the breakdown of question 1 will be this type of question. Question 2 will be that type of question. I'll send that out tomorrow, so you can look it over, and then also look at the practice tests on my website. I'll send out all the information related to that. But one thing I can tell you is that most of the test is going to be related to the same data set, which is good news and bad news. It's bad news if you screw it up when you type in the data. You're going to get like every question wrong. So that's going to suck. But if you verify that the data is typed in correctly, then it means that you don't have to continuously, throughout the entire test, waste all the time just typing in data. You know? And so the added component to that is when you finish question 1, don't clear out your data, because you're going to need it for question 2, 3, 4, 5, and so on. All right. Anyway, that Calc 4. Let me get these out of here because it looks like they're related to this problem and they're not. Well, this one's fine, but the other one isn't. Stat Calc 4, L1, L2, and then do what you got to do. Alpha trace Y1, and then calculate. Much shorter data set, so it goes by a lot quicker. It says done. We get this great looking R squared and R value. So here's that typo that I was talking about. It said compute the linear correlation coefficient. I also wanted and coefficient of determination. Oh, jeez. All right. That's supposed to say coefficient of determination. I'm sorry. I'm trying my best here. All right. Sounds like I'm adding a ton of work to this, but not really. This is our coefficient of determination. And this is our correlation coefficient. I'm just abbreviating like crazy here because it's really not serving much of a purpose for me to try to write out these words. All right, so it also said determine the linear regression equation, but we already have that. That was already there. So y hat, don't forget the hat, is equal to 1.643 x plus 1.676. So the last part of the problem is determine if there are any outliers or influential points. All right. Now this data doesn't have any context, so we can't use that to our advantage. You know, if there was context, we could say, well, that number doesn't belong there because I know what this is all about. You know, it's related to like ages of kids in an elementary school or something like that. Not the case. So we can't go off the context. We just have to go off the raw data. So we take a look at the picture. It's still set up for the stat plot, which is great. So zoom 9. One thing to be cautious about, cautious is too alarming of a word. We still have that 25, when you hit y equals, we still have that 25 in there from that last problem. So if you get a stray horizontal line when you're trying to do a correlation, you know, scatter plot, linear regression, all that, odds are it's from a previous problem. So if that shows up, it didn't show up on that one because the data values were so small. If it shows up, just go into y equals and clear it out, and it'll be fine. So this one, I think it's pretty obvious that there would be no outliers or influential points. All right, because again, we're calling an outlier a striking deviation from the overall trend. So no outliers. Or influential points. And again, that's the thing that tends to throw people for a loop, because it's like, well, what mathematical process did we use to determine that? I used the eyeball method. And that would be just looking at the graph. How do you know if it's striking? Well, does it look striking? No? Okay, it's not striking. Yes? Okay, it's striking. Right? So it's in the eye of the beholder. Question, Juliet. Yeah. It's all right, though. It happens. So stat, calc 4. When you get to this menu, make sure in the store regression equation, you type in the y1. So alpha trace y1 before hitting calculate. Once you do that, then it'll store that equation in here in y1, and then when you hit graph, it'll show up. The y hat equals. Yeah, y equals in your calculator, y hat on paper.
So if there were outliers, you would just say that there were outliers, or there was an outlier?
Depending on, yeah, if it's some point that's kind of up in this neighborhood, we'd call it an outlier. But if it's a point down over here horizontally deviating, actually I would even say more like over here, then we would call it influential. Right?
I was going to ask if we always have to write the influential points.
Not always, because influential points are a subset of outliers. So if you say that there are no outliers, you're also saying that there are no influential points. But if you're stating that there are outliers, you would then also have to address whether or not there are influential points. Okay, so if I say there are outliers, then I have to be specific. They're either just outliers or they're influential points. But if there are no outliers, then it's assumed that they're not influential either.
That would also be in the eye of the beholder, right? To determine whether or not you want to call it an influential point.
Right, exactly. But there is like the borderline cases that could go either way, and then there's like, I know I said eye of the beholder, but that one's like all the way over here, and you said it's not an outlier or influential point, so, you know, -1.
You ever see like issue neighbors to mouth and see if there's a picture?
You could, but the thing is, when you hit zoom 9, it's plotting, or it's giving you a window that fits all the data points. So there are no data points that are off screen, so you wouldn't have to worry about it. You know. So this we're not doing. because that is in your tech assignment. And we're not going to do that or that or that.
That's a typo, right?
No, it's just some semester. Well, this time it's not. But what I'd like you to do for homework, not homework, like to do some stuff before next class that I won't be checking grading or anything like that, would be this page. And if anybody can let me know what page this is, that would be just 20. Oh, we're already up to page 20. That's great. Yeah, some semesters I do those extra topics, and some I'm like, I don't want to. And this is one of those semesters. We're all so devastated. All right, so that's where we're going to leave it for tonight. And so we're done with the unit in terms of new material. So next class we'll go over this material and then, or this page, and then we'll have open forum Q&A to review for the test. So be on the lookout for the breakdown of what's going to be on the test. And you can already, you don't have to wait for me. If you go to my website and you look in the extra practice and review section, you'll see the old unit tests. All right, they're pretty much what you can expect to see. You'll see a different data set, but that's what the test is going to be. So there's no surprises in this class.